Hello everyone, your Dr. Zia Tahir here. This video tutorial is solution to example 8.18 of mechanical vibrations, 6th edition by S.S. Rao, and it is about solution of frequency equation of a beam for multiple root. Description of problem: develop a general Matlab program for finding roots of nonlinear transcendental equations. Use program to find root of this equation, which is tan beta L minus tan hyperbolic beta L is equal to 0. So that is the equation uh, I'm going to solve for its five roots. So objective is to find five roots of the equation. So, and to solve this type of equation, which are nonlinear and transcendental, so there are several methods in MATLAB, but the easiest one is using solve function. So solve function in MATLAB is solve equation in symbolic form. So that is a simple one. So solve. So that is equation, a quadratic equation. So to solve that one, you need to develop that same a, b, c, x, and then write equation, and then simply solve equation. And if you're just using solve, so it give you in symbolic form. And if you give a particular value, and if the values are given, so then you can get its roots. So the function which is being used here is VPA solve. So what that VPA solve function do, it takes an equation, and from that equation it find a variable, but this VPA that numerically solves that equation for an initial guess. So initial guess or a search range, which is initial parameter. So whatever is initial guess or search range in which need to search the solution. And then the other one command is being used double, so which converts symbolic values to double precision. To solve this problem, I am going to use MATLAB 2023A, and this is a standard layout or default layout. That is default layout, and I'm going to start a new live script. So new live script, like it has some better improvements compared to script. So you can have here results either on the right side or in line. I saved that script as 8.18 and I'm giving heading to that script as example 8.18. So with double percentage sign, and if you press enter, so you will get heading of that example 8.18. Then to clear screen, and then to clear workspace. Okay, and then I'm going to start that SYMS, so symbolic system, and then BL, because equation here is tan beta L minus tan hyperbolic beta L equal to 0. So here the variable is I'm going to define that beta L, and in the same you have to define that, and then need to type eqn equation equal, that is tan beta L, and tan hyperbolic beta L is, so equation equal tan beta L minus tan hyperbolic beta L is equal to 0, and then suppress it. And then the function I'm going to use here is VPA solve equation, and the variable is BL, and then I'll give initial parameter in the search range. So VPA solve, that is a function, and then equation, which is I have already defined. then the variable, and then the search range is between 0 to L, and whatever the value will come. So I'm going to save that as BL. Okay, so in live script, you can have results on here right, or you can get parallel results. So I'm going to run that and then try to find what is the value of BL. So it gave me BL between 0 to 1 as 0. Or then I'll go between 0 to 10 and I run it, and then it gave me again a value 0. And let's say from 1 to 10, so it is 3.9. So if I run it again, so now between 1 to 10, it is going to give me the lowest value, and then between 5 to 10, it give me the other value. So this equation that has many possible answers, and the minimum like is a 0. So then to get all possible answers, so need to I'm going to run a loop for this. So it will take any value between any integer values, and then it will give the solution. So I'm going to write a apply a loop for this so that I'll get like first three, first five, or first seven roots of that equation. So for the same script, BL is equal to VP, a solve equation BL I to J. I run a loop. So first I initiate a BLI, an empty matrix. So then I from 1 to 10 with the step of 1, and J is equal to next value of that. And then it converts whatever the value is coming, it converts to the double, because this one it will give it a symbolic value and then double, and then it will write all those values. So between 1 and 10, and then I am going to get the values. I'm going to get the values. So here output is in line. I'm going to set and run it. So what it will do, it will try to find the values between 1 to 10, all possible values. So in the form of integers, so that is the first value. Or if I run from 0 to 1, so it will give first value as 0. But I'm not interested in so 1 to, then I'm going to run it for 1 to 15, and then to, because I'm interested to find five roots, so then there are four roots. So 3.92, then 7.08, then 10.21, and 13.35. And then let's say if it is 20, so between 1 to 20, so there are six values, and the last value is 19.1. So then, so these are first six roots of this equation, which is here. So this is a problem here, like example 8.18, and here are the roots 3.9 to 7.06, and then 10.21, 13.35, and 16.49. So the roots which I am getting here, they are very much similar. So in this way, uh, it is possible to find roots of this equation. So these values of beta L are used to find natural frequency and mode shape of different beams.